find V out in this circuit in general, so for whichever V in we have at the input. That means that we're going to have to study 4 cases for the diodes, and we're going to say they're either on or off, how much is V out in each case, for which V in this will hold true. Step number 1, identify the points before and after the diodes. So I identify these 2 points. This point is common, it also has a voltage that I know, V in. These 2 points I don't know, so I will name them L and M over here also. Now I'm ready to go to step number 2, set up the conditions for the diodes. So for this diode to be off, it should be Vm minus V in less than the VD on 07, 0.7 volts. How about here? Again, for D1, it should be V in minus VL less than 07 volts. A diode that is off is basically an open circuit. How much is the voltage on these points? Basically 0. Why? Because no current flows through these points or through the V out over here, right? So it's basically Vm is equal to VL, which is equal to 0, which is also equal to V out, which we know we can't have since we don't have a closed circuit. Yes, even in this case over here, where we have this battery, because this battery does not have a close connection between both of the terminals. That means V out will be 0 when this is 0, this is 0. And if you do the math, you will have that when V in is less than 07 and more than 07, minus 07, V out will be 0. Case number 2, D1 is on and D2 is off. If D1 is on, will be represented by a battery with these polarities, be very careful, with 07 volts. Now again, I'm going to write my conditions for the diode, so it will be V in minus VL must be 07 because the diode is on. How about the 2? Vm minus V in must be less than 0.7. How do we proceed forward now? Vm, alright, we know that Vm will be equal to the voltage over here, which will be V out. Why? Again, because this does not close a circuit between these 2 terminals. That means that Vm will be V out. Alright, I eliminated this. How about this voltage here, VL? Well, there are many ways to proceed, but this is the best. There is a current flowing from here all the way to here, all the way inside this node, starting from the input and going all the way to here. Now, where can this current flow? Only to the ground. That means that this current is the same as this current. So what I'm going to do is basically perform a KCL over here. I'm going to say that this current, I'm not going to name this, I'm going to resist the temptation of naming more variables. I'm going to use other variables from the system that I know. So, VL minus V out, the voltage difference, remember, over this resistor, will be equal to the current that flows from here downwards. So, V out minus 0, the voltage of the ground, I'll not write it, over R2. And now we basically have a way to connect VL and V out. Very simply, we solve this system. VL is basically this expression times V out, which now I can go ahead and replace over here. Alright, or I can replace V in minus 07 here. So if I replace this value from above, it will be. So V out is going to basically be when this condition holds true. So Vm is Vout. How much is Vout? It's this. So I go ahead and replace this inside here in my conditions. So for Vin being more than this value over here, Vout will be like this, which I suspect that this will hold true when Vin is going to be slightly less than 0.7 up until this 0.7, right? Now going on the third case, D1 is off and D2 is on. If D1 is off, it will be represented by an open circuit again, and if D2 is on, it will be a battery. Now, what is the first thing we do? The conditions of the diodes. V in minus VL must be less than 0.7. Vm minus Vin must be exactly 0.7 because the diode is on. Right, how much is VL? Well, VL again will be Vout. Thankfully, we have another condition over here that is not very easy to see. This point and this point are separated by a battery, which has a standard of 2 volts. That means that Vm minus Vout, the voltage here minus the voltage here, will be equal to 2. That's very difficult to see if you're not familiar with these circuits. And now we can basically solve this system because we know all the unknowns. So Vin minus Vout will be 1.3. Vin minus Vout must be less than 0.7. And if I go ahead and replace this over here, I'll have that 1.3 will be less than 0.7. As far as I know, this cannot hold true in the physical world. This means that the proposition that D1 is off and D2 is on is false. This can never happen. Last case, both diodes are on, so I go ahead and replace also D1 with a voltage source of 0.7. Now, what's the first thing I do? I don't panic. What's the second thing I do? The conditions of the diodes. Right, both diodes are on. Now, I must eliminate Vm and VL from these equations. How much is Vm? Well, working similarly to previously, Vm minus V out will be equal to 2. Now I'll go ahead and replace this over here, and I have the relationship between V out and V in. That means that in that case, V in will be will be V in minus 1.3. Because the condition for which this is true is going to be the condition that was not covered in the previous cases. Because the diodes have to be on or off. They must have two conditions. So for all other cases that were not covered over here, these two diodes will be on. What are those cases? Very simply, when V in is less than minus then and only then the two diodes will be on and this will hold true. So let me draw it for you here. For this bin, for some negative value of infinite up until these points, both diodes will be on. When it reaches that point onwards, this one of the diodes will be off. When it reaches 0.7, this value, minus 0.7, both diodes will be off. This will hold true up until plus 0.7 here. From where onwards, again, one of the diodes will become D1 will be on and D2 will be off. And from that point to infinity, this will hold true. I know these concepts can be a bit hard to digest sometimes, so don't worry, with practice, you'll pull through. I'll prepare more exercises like this in this channel. Check out the diode playlist over here. Study well and take care. Bye bye.